Hello everyone, we are Team 11 and Nikita Karnal. We are presenting the predicting injury severity in road crashes. Our main agenda at this project is to follow the CRISPR methodology. CRISPR methodology is one of the widely used methodology in data science and data analytics projects. If CRISPR methodology combines with agile project management, we can get the best results out of them. There are 6 steps to follow in CRISPR methodology. They are business understanding, data preparation, modeling, testing and evaluation, and deployment. Coming to the executive summary part, in this project, we are aiming to determine the factors that affect how serious an injury in an incident and the factors contributing to that. We are using different modeling techniques, out of which we are using random forest, ANN, Navi bias, decision tree, and logistic regression to determine the factors contributing to injury severity. In this data set, we have 202 attributes, out of which we have chosen 32 attributes for analysis and used as an input in these models. While performing random forest, like we have deduced an variable importance graph, and according to the variable importance graph generation, the weight of the vehicle and occupant ejection status as the most relevant attributes, while speed of the driver related to the crash and driver's attention to the driving are the least relevant variables. With an accuracy of 89.6% and ROC of 95.13%, random forest has performed the highest accuracy. While coming to the Navi bias, it has performed the least, with an accuracy of 81.6% and ROC of 88.1%. As a result, government and automobile manufacturers can utilize the random forest modeling technique as the best one to predict the severity of injuries in traffic accidents, thereby enhancing the road safety. Coming to the business understanding phase, in this phase, we need to identify the objectives and requirements of a project in a business perspective. As we know, in US, there is a significant risk due to the cars, as the infrastructure of the roads is not well developed. So due to this, in according to 2021 statistics, 49,000 injuries were happened only during the road accidents. As the data set given is like very huge, like we need to identify the missing values and the relevant variables. In this business understanding phase, we need to implement the best fitting modeling techniques that we have. Choosing a plan of project from a business perspective and identifying the factors that contribute to injury severity. As there are like many factors that contribute to injury severity, out of which environmental factors, driver's negligence, and alcohol usage are the main factors contributing to that. Coming to the data set, we need to analyze the data set in the best way we could. Predicting the level of injury severity and identifying the high and low factors contributing to injury severity also plays a major role in business understanding part. In this phase, like we need to deal with the accuracy, sensitivity, and specificity of various models. As this is the main step in CRISPR methodology, the main focus should be this step. And in this step, like we also have an opportunity to, as an analyst, like to create awareness among the people and finding the most effective campaigns to reduce the injury severity, or else like to motivate the people regarding the road accidents and the factors contributing to them.
Hello all, my name is Shreya Arora and I will be discussing the data understanding, which is the second step of CRISP-DM. This step is used to assess the quality of the data and also to explore the attributes of data. Our datasets consist of 4 different files, which are accident, vehicle, person, and distract. They have their own characteristics. We used left join in 9 to merge these files together into single dataset, and the final dataset consists of 130,288 records and 202 attributes, out of which 196 are numeric and 6 are nominal. Therefore, we can clearly see that numeric attributes dominates the nominal attributes in our dataset. To the right, we can see the 9 workflow for performing the joining operation. We also explored the data using Data Explorer and Statistics nodes in 9. And one of the most important attribute in our data set, which requires our attention, is injury severity, because that is our dependent variable. To the right, we can see the distribution of the injury severity variable, and we can see that the values are ranging from 0 to 9 for this variable. Other than this, the skewness and kurtosis of this variable clearly shows that the distribution is far away from normal and heavily skewed. Also, 0 and 1 are the values which are dominating for this particular attribute. The next most important step is data preparation. This is the step of crisp DM which requires a lot of attention, time, and effort in every data mining project. First, we should select the data, and we came up with 34 relevant attributes for our models. We also reduced the rows which were not relevant to our modeling techniques. For example, in injury severity, we just kept 1, 2, 3, and 4 values because the others were accounting for not applicable and unknown values. We used row filter to complete this job, and the dialog box in the right shows that how we implemented the lower bound and the upper bound to implement this. We also used missing value to replace the numeric and nominal missing values. So for numeric, we replaced with a median, and for nominal, we replaced with a fixed value called missing. The most important node in our project is numeric binner. We did the binning technique to reduce the cardinality of the data, which represents the uniqueness. Suppose if there are many unique values in a particular column, that column is of no use in determining the output. For example, we binned day week into 3 bins, which are weekday, weekend, and one more weekend to represent 3 different values in the weekend category, which are Friday, Saturday, and Sunday. We also binned many other attributes, and the whole list will be presented in the end. Constructing new data is also one of the important steps in data prep, and we used equal size sampling, smooth, and one-to-many for this purpose. The only difference between equal size sampling and smooth is equal size sampling used undersampling, whereas smooth used oversampling. Both of these techniques are only applied to the training data because our testing data has to be genuine. These techniques are performed by adding artificial rows to the data. One-to-many nodes create many new columns out of a single categorical column based on the unique values of that column. We use normalizer to normalize the numeric attributes between 0 to 1 so that no numeric attribute can dominate the other one, and the whole 9 workflow for these nodes is given at the bottom. The final list which we used for our models is given in the left-hand side. We came up with this list based on the relevant and promising factors such as weekdays, alcohol use, drug use, and many other characteristics. Out of these attributes, we binned a lot of the attributes, and the list is given in the right-hand side. This is the overall 9 workflow we used for our modeling. We can see that we used 5 different models, each with their own annotations in the 9. And in the right-hand side, we use the ROC curve to represent every curve in a single output. These models will be discussed in detail by one of our team members, which is Parker. Thank you.
Hello, my name is Parker. I'm going to be walking you through the model building process of our study. The first model that we used was a decision tree. On the right, you'll see a decision tree view with 3 levels and splits. And at the bottom left, you'll see an overview of our 9 workflow with the decision tree. Decision trees are very popular as classification models because they're very simple, as you can see from the tree view on the right. They can also serve as a check to make sure that you've prepared your data correctly. Our decision tree uses k-fold cross-validation with 10 folds to partition the data. Also, data going into the learner node goes through an equal size sampling node so that it equalizes the number of low and high results for the independent variable, which is injury severity if it's low or if it's high. The next model we used was an artificial neural network. Specifically, we used a multi-layer perceptron, or MLP. The MLP is the most widely used neural network model for classification problems. For this one, we used what I call standard partitioning in this presentation, but what I mean by that is rather than k-fold cross-validation, we just used a standard partitioning node which splits the data 70-30, and the 30% is a stratified sample of the target variable. Because neural network models require numerical data, we used a one-to-many converter and a normalizer, which had the min-max setting 0 to 1. And the only variable we excluded was the target variable, injury severity. Most of the other variables were string because using the binner converted everything into string. The next model we used was a random forest. A random forest is an ensemble model, which is just a bunch of decision trees. You're able to adjust this within NIME, and we decided to use 100. It still used the standard partitioning with the 70-30 split. However, instead of using an equal size sampler, we used a SMOTE node, which oversamples the minority class to balance the data into the learner. Using the attribute statistics output on the random forest learner, which is the middle thing, the second triangle, it goes into the Excel writer, which we use to make a variable importance graph, which is in the next slide. As you can see on the variable importance graph, most of the variables toward the top make sense for whenever you think about crash severity, how heavy the vehicle is, whether the people in the vehicle were ejected, the results of alcohol tests, whether seat belts were used, and the manner of collision, like if it was a head-on or if it was a fender bender, side swipe. The fourth model we used was naive Bayes. The naive Bayes model assumes that variables are independent of one another, and this model is based on Bayes' theorem. This model used standard partitioning and an equal size sampler, like several of the others. It utilized a default probability of 0.0001 and a minimum standard deviation of 0.0001. And of course you can see the workflow on the right. The final model we utilized was logistic regression. You can see the workflow there. Logistic regression uses numerical values, much like the neural network. So this data all is derived from the same nodes that gave us our neural network data, the one-to-many and the normalizer. Logistic regression is useful for classification because you can get a mathematical equation out of it, and that provides some transparency, whereas something like the neural network you don't get quite as much transparency from. You're not really sure necessarily how it made the decisions it made, came to the conclusions it did. And the solver used in the logistic regression learner node was the stochastic average gradient. Next, we will talk about testing and evaluation of these models.
Hi, my name is Patrick Woolwind, and I will be going over the testing and evaluation, the testing results, the deployment, and finally the conclusion. So I will now go into the results of our testing. Now the models produced exactly what we intended them to. We have a better understanding of the factors that affect injury severity between low and high. Many factors affect the injury severity in a motor vehicle accident. After modeling the data of thousands of accidents and using 5 predictive models mentioned earlier, we were able to determine that overall, the variables most affecting high injury severity included ejection, blood alcohol content, and whether or not a restraint system was used or seatbelt. Now, in order to rank models, we needed to take a look at the models individually and assess their performance. Luckily, there are ways to assess the test based on several factors, which include specificity, sensitivity, accuracy, and precision. Now, precision and sensitivity specifically are included in a measure called the ROC curve, which allows us to measure the area under the curve. The ROC curve is a graphical curve of plotting the true positive, which is the sensitivity, to the false positive, which is precision rate. And it's the accuracy measure of a classifier. So a value of 1 is a perfect classifier, and a 0.5 is no better than a random chance. Now, based on area under the curve, we see that the random forest model, denoted in the pink on the graph, proved to be most useful. So we see here that we also added in the accuracy. Now, when it comes to accuracy, which is basically your true positive and true negative, accurately predicted by the predictive model, we see that random forest really has the highest percentage there at 89.6%, meaning that 89.6% of all the data was accurately predicted by the random forest model. Thanks to the decision tree and the random forest, which provide a more visual look into our data set, into our problem statement, we understand that the 3 most important factors affecting injury severity during a motor vehicle accident include the ejection alcohol result, or which is blood alcohol level, and the restraint system used, whether it was used at the time of the accidents. And so what can we do about this? So we have developed some recommendations, and our deployment recommendations include the following. So one is to develop a social awareness program. Now, the issues facing high injury accidents include not wearing seatbelts, not drinking driving, really 2 of the most obvious reasons, yet decisions which need to be made by the driver and those around them. So developing a social awareness program may help with this, to bring more awareness around the topic and really drive the point home to make the right decisions. Now, another option is to work with lawmakers to enact tougher penalties on individuals not using their seatbelts. The one thing we can help in this individual decision-making process is to increase the penalties for drivers and passengers who choose not to buckle up. Enforcing this simple rule may remind people to always buckle up. Additionally, we can also work with lawmakers to enact harsher penalties for manufacturers who do not adhere to proper seatbelt guidelines or are found to have faulty seatbelts. Now, this may cause small increases in cost to manufacturers, understandably, to place that secondary check in the manufacturing process, but it could very well save lives. So in conclusion, like we mentioned, the predictive models provided the information that we intended them to provide. It allowed us, gave us understanding the determinants of high injury severity in car accidents compared to those giving us low injury severity. And, we used the different techniques, the 5 different techniques and prediction models to provide answers to our questions. So some might have had higher accuracy, while others might have higher precision, sensitivity, or an ROC value, but they all served a purpose, and we wanted to see which of the 5 models provided the best results. And like we mentioned, decision tree had the lowest ROC value, but did provide us with insights. It was one of the more visually appealing models because it provided us with a breakdown, if you will, of if and then statements that give us the data of the top determinants of high injury severity. We also have the neural network, which provided us ample amount of data, naive Bayes, random forest similar to the decision tree, but really as many different decision trees. Also provided a good amount of data for us and really had the highest accuracy of all the models. And then also the logistic regression model that we constructed as a team. So and that concludes the presentation. And on behalf of the entire team, I'd like to thank you for watching.